So it's recording. So let's start. So from the very first class, we have actually discussing only this one, that overview of the computer. That whenever we actually can see the computer from a user perspective, we actually can see in this way, right? In this way. So what is actually that means that in a computer architecture, any computer architecture, whatever you can see in any computer architecture, we actually have 6 different stage or level of steps, as you can see, from 0 to level 5. So as a normal user, as a very, non-technical user or just normal user, is actually started from level 5, because in level 5 we user actually interact with the computer in level 5. So as you can see that it's a word processor, normal software what you're going to use. And we know that in level 5 for the user is a very, very limited access to the system level. Okay, because for example, if you want to use a Word file or with Microsoft Word, what actually we can do, we just write, edit, add something, but we don't have any, control over the system. We have a little bit control, very limited control. For example, we can just print it. We can choose the printer. We can change the printer, something like that. But we don't have any control over the printer. So that's why it says that in level 5, user have a very, very limited control over the system. Okay, and if you go to one level down, which is in level 4, which is we call high level language. We all know that what is high level language. It's a C, C++, C#, Java, Python, whatever, right? All of them are high level language. Why they call high level language? Because whenever we try to write the code on this high level language, the language of that code and the syntax of the code and the language of the human is very similar, is very, very close to human language. So that's why we have a very feel comfortable to write it. And that's why it's called high level language. Okay. Another most important of these two levels, level 4 and level 5, is they are system independent. So why they are called system independent? Because wherever you use this, doesn't matter is a Pentium 2, Pentium 4, Core i5, Core i9, 9th generation, 10th generation, or whatever motherboard you want to use, it will work. If the minimum system requirement fulfilled, then you actually can install and you can actually use those software. Same as a level 4. If you have a C compiler in any system, if you have a Java runtime environment in any system, you actually can run those code. You don't need to change those code, right? So that's what they call system independent. But if you go a little bit down, one step down, which is level 3, 2, 1, and 0, then, for example, our current language, assembly language, right? So in assembly language, what actually is, it's system dependent. Why you call it system dependent? Because as I told you several times, I'm telling you again that whenever you need to write an assembly language, we need to consider about the system. For example, my one is Pentium Core i5 9th generation processor, right? I have 16 GB memory and I have a gigabyte motherboard. So whenever I need to write the assembly language, I need to consider what is the architecture of my processor, which is 64-bit processor, and then what is my RAM, what is the structure of the RAM. So I need to consider all this whenever I want to write the assembly language. But whenever you write your assembly language, you also need to consider what is your system. My coding assembly language in my system will not work in your system, okay? Because it's totally system dependent. Because the architecture of the processor, architecture of the RAM, the architecture of the data bus or address bus, they might not be same, right? So that's why assembly language totally system dependent. If you go a little bit more down, level 2, which is the machine language, of course, it's again is system dependent, because the machine language is just 0 and 0, 1. So whenever you write any instruction, whenever the instruction, let's say for the instruction for my RAM, might not be same as the instruction of your RAM. Okay, it will work only by this one. So if you want to change this one, then you have to also change the machine language instruction. Then it will work. Otherwise, it will not work. Okay. For example, as I told you that my wireless mouse, okay, it is working into my system because whenever it is also plug and play. I also, by the way, discussed what is plug and play. So when I add this one to my computer, my operating system detect it and install the software for it. Okay, but if I change my mouse to any other PC and that PC cannot detect it, right? It cannot work because it cannot detect it. Because if the operating system needs to detect it, it needs to install the device driver for this mouse and then it can work. So if you attach this mouse to any other PC and where it cannot be detected or it cannot install the device driver software, it will not work. So that's why it's a machine language, also actually hardware level also. It's actually system dependent. Okay. How about the operating system? I told you also as an example that operating system, whenever you, Mahmoud Hassan, please wait a little bit, let me finish. So whenever you have install an operating system, right, to any system, the operating system, what actually it does is actually install or make an environment. By the way, operating system is nothing but just making an environment. So it's making an environment for your computer system, considering all of your equipments, all of your system, and then make an environment. So if you take this operating system to the other machine, it might not work because operating system consider all of your system to make it an environment. But if you change the environment, if you change the system, you need to either reinstall it. Of course, you need to reinstall it. If you don't reinstall it, then it will not work into the other system because your other system is different. Your processor is different. Your RAM is different. So if it is not reconfigured itself, then it will not work into the other system. That's why also operating system is also a system dependent. Okay. How about the plug and play? I hope you remember what is called plug and play. For example, my mouse, my keyboard, my monitor, my headphone, everything is plug and play. Why it is plug and play? Plug and play means whenever I plug, let's say with this mouse, I have a little bit USB dongle, right? So whenever I just put the dongle into the USB port, on the bottom right corner, you can see that a new device is detected. The device is installing or sometime. So after some time, let's say 30 seconds or 1 minute, it's also saying that your device is now ready to use. That means within these 30 seconds or 1 minute, my operating system detect that it's a wireless mouse, it detect that it's a F4 and it's detect that it's using 2.4 gigahertz Bluetooth, right? So then it install the device driver software for this mouse, and then after 1 minute or 30 seconds, now it is ready. Okay, so that is actually plug and play. Previously, human needs to install it by itself, because I also buy another thing whereby I buy another keyboard. The keyboard also has an installation CD. But now, as I said, that our operating system is very smart. We don't no need to install any device driver software by ourselves because our operating system is very smart now. They actually go to internet and then they download the software for the device driver software and install it by itself. This is actually the plug and play, right? So they install our operating system, install all the necessary utility software, device driver software by itself. That's why it's called plug and play. So if you just plug it, it will start running. All right. So that's why it's called plug and play. It's a very important one. Okay. So that is actually the overall idea we have discussed the last two or 3 days. Yes, Mr. Mahmoud Hassan, you have a question.
Sir, can I please ask in Bengali?
Sorry, what is it?
Can I please ask in Bengali? Can I ask the question in Bengali?
Oh, Bengali? No. Okay. No, please. Please don't speak. Oh, by the way, very good point that please do not speak to me in any other language rather than English. Please, whenever you also call me, please also speak in English. Please, all right?
Sir, okay, sir. Sir, is the operating system, sir, now really system independent, or is it like that the operating system contains all the CISC and RISC constructions so that it supports on both, and we are only using mostly CISC and RISC all over the world. But if any new architecture comes, it will not work. So it's basically system dependent, right? But
which one?
Sir, operating system or everything?
Okay, there are different ways you actually can explain this one. Generally, normal point of view, theoretically, it is now still system dependent because As I told you that if you install anything, there are some specific instruction set for your system, right? If you change the operating system to the other system, theoretically it will not work, okay? But I told you there are some exceptions. For example, Ubuntu, for example, some of the other Linux, for example, maybe Windows 10 also, they have a feature called, what is that feature name? Portability, right? Portable operating system. So now there is a new feature that you actually can carry your operating system to the different devices, but it is not, it doesn't mean that it's still system independent. It's not system independent. What actually it does, whenever you carry your operating system from one system to another system, you actually, as I said, now the operating system are very smart. So whenever you change it, operating system will not allow you to feel that it's actually on background, it's actually prepare itself to make it run in the new system, okay? So they're actually smart enough to, I mean, prepare themselves to work in that new system, okay? That's why from the user point of view, we are thinking that yes, now operating system is working in this system and that system, so it's actually system independent. It's actually from user point of view, now it's system independent because the operating system is very smart. But developers point of view, on the background, it is still system dependent, all right? Okay, so now that's why you actually can see that yes, any operating system can detect anything. The reason is, as I said, that behind it, you actually can do a lot more because some of the operating systems also have a very good, I don't know, on the behind if they're using the AI or not. Of course, I think there are some artificial intelligence attached with the operating system because what actually when I use, for example, I'm using Microsoft Professional, Windows 10 Professional. I can feel that some of the features are very, I mean, smart. Sometimes my computer actually know my habit, what I'm going to use, what actually I use, what is my preference, something like that. So it's actually now very smart. I think, I'm not sure yet, but I need to do a little bit study also that now our operating system are also very intelligent. Okay, previously our operating system is very like dumb thing, but now it is really very smart and it's also very intelligent, sometimes much more intelligent than us. I mean our normal user, right? So we actually cannot feel some of the thing, but I actually, when I try using my Windows 10 Professional, is actually I can feel that it is now much more, I mean, smart enough and have very good intelligence. It actually can track my behavior also, what I use, what I'm going to use next, what I do, when I write, what I'm going to write next, he actually can guess. I hope you also can see whenever you write email, to reply any email, it is automatically writing by yourself. Did you see that?
Yes, sir.
Did
Yes, sir.
anyone
Yes, sir.
did
Yes,
you
sir.
see that? Yes, whenever you try to write, it's already know that whom you are writing and what you are going to write. And
Yes, sir.
some of the times, not only mail, in any other application also, whenever you try to start writing, it actually can guess what actually you're trying to write. So it is also as a machine, I mean, machine learning and AI and everything. So our operating system is now very smart. Anyway, I hope you have the answer. Do you have any other question, anyone, so that we can go for the next one? It's fine. All right.
No question,
So
no question, sir.
no question. All right. Thank you. So let's go to the next topic. By the way, we already know that what is the machine language and level 1 and level 2. All right, fine. So now, actually, my plan was, I actually have a specific plan for each classes. My plan was today I will teach you or discuss you about the CISC processor and the RISC processor, because this full assembly language we actually divided into two parts. As we know that all the processor are two types. Let me see, there are some, just 1 second, because there are some chat option. What is it? Yes, I recorded it. Yes, I recording it. Okay, thank you. So as we know that we have two types. So if you divide the whole types of processor, whatever is available in our market, we actually can divide the processor into two different categories. First category, CISC. As you can see, the full form is complex instruction set computers, and another one is the RISC. RISC is reduced instruction set computers. So these are the two types of microprocessor. And as we know that whenever we try to write our assembly language, and we need to consider the processor architecture, that's why the way of writing of the assembly language or the structure of the assembly language also have two types. That's why we need to know what is actually CISC and RISC processor. So let's start with the CISC processor. So CISC processor is one kind of processor. It's very common and very popular nowadays. But what is the CISC processor? CISC processor is this processor architecture allow the user to write a code which is very simple structure, simple instruction, and that simple instruction actually integrated with all other instruction inside it. Okay, let me tell you again. Whenever you write an instruction or algorithm, assembly language in CISC architecture, the way you write in the CISC architecture is, it is a very simple code, right? Like one line or two line. But in that simple one line or two line codes is actually the combination of so many other code also. That's why it says that, as you can see, it's written from the book, maybe, I don't know. Yeah. The processor is single instruction can use several low-level operations. That means you are writing one single instruction, but inside this single instruction, there are so many other low-level assembly language. For example, it can be load memory, it can be any arithmetic operation, it can be any memory store or anything else. Okay, and it's also capable of multi-step operation or addressing mode within a single instruction. Okay, I will give you an example, so don't worry. So what is the, so this is actually the basic thing. What is a CISC processor? For example, if you want to add two number, okay, let's say you want to add two number by using the CISC processor, you just need to write add, add. There are so many types of add also, but just less for simplicity, you just need to add variable number 1, comma, variable number 2. That's it in the CISC processor. What actually it can do, variable number 1 and variable number 2 is actually added together and store it into the variable number 1. That is the CISC processor. But if you compare with the RISC processor, same add operation, we need to write 3 to 4 lines. For example, we need to load one variable into the one register, then you need to load another variable into second register, then we need to add it, and then you need to store it again. So 4 needed for the RISC processor. That's why they are actually saying that in the CISC processor, single instruction can be executed several low-level operations. Okay, I will give you an example. So just remember this one. But the problem is, whenever you try to combine all this code into one single code, it will make it short, but it will make it more complex for the system. It is easier for us to write just one line, but it's not easy for the system to execute it. That's why they actually call it complex. I hope you understand that why it is called complex instruction set computers, because the way we write it, the way we design our assembly language, it is short, but it is complex for the system. Okay? Okay, so now let's proceed. The CISC processor were also helpful to simplify the code and making it shorter, all right, to reduce the memory requirement. By the way, why we make shorter, the way is, whenever is actually invented the CISC type of microprocessor in 1970, right? In that time, the space of the memory is very limited. The space of the hard disk is very limited. The resource of the microprocessor are very, very limited, right? And it was very, very expensive at that time. So to overcome this problem, they actually using in this way that, okay, we have very limited memory, we have very limited register, we have very, very limited the resource in the processor. So let's use it as much as possible rather than we use everything. So that's why they actually invent and allow the processor to make it very, very short way so that you actually can save the memory. Okay, so that is the reason actually they invent this type of processor. Okay, I mean, yeah, architecture of the processor. So let's have some example of it. Okay, as I told you that CISC processors are very, very popular nowadays and also previously. As you can see that it's using Motorola 6800, 6809, 6800 families, and most importantly, you actually know these two, right? Intel 8080 family and also Intel x86 family is very, very common because all of our PC, all of our Intel, if you're using Intel, they are actually using this x86 family also, and 8051 families have also some embedded system, very small processor, but these are very, very common. Most of our PC nowadays actually are using CISC processor, although there are some exceptions. Okay, I'm not telling the exception now. This is just a theoretical thing. I will explain. We will learn more and more about the CISC processor and RISC processor. But now, just try to understand that CISC processor is very common now. It is widely used, and it is used for most of the type of the processor we can see around us. As you can see, all the Intel and everything. So that is actually about the CISC processor. I will give you an example. Don't worry, please have a patience. So let's see what is the advantage, why we need CISC processor. As you can see, the core size is comparatively also, of course, very short, all right? And which is also minimize the memory requirement, because if you just write one line, that means you just need very short amount of memory, rather than you are writing 4 to 5 lines for one instruction. So if you want to write 4 to 5 lines, that means you require more memory. It required more registers, something like that. So that's why it's actually comparatively shorter. Of course, it is less amount of memory, and also execution of the single instruction accomplished with several load. That means you don't need to write so many other code. If you just write one code, all other related code will also work. Low-level language code. Right? So that is also very good advantage. Complex addressing mode makes it memory access flexible. That means this generally the CISC processor using more of the memory. So it's actually to memory rather than to register to register. Generally, the RISC processor using the register, okay, of the microprocessor, but generally the CISC processor is using the memory location. All right. We will also discuss the difference between CISC and RISC very soon. So please wait. So another last advantage is CISC instruction can directly access the memory location, because the CISC processor, as I said, is using the memory location. So these are the all advantages. Hopefully you can get it. If you have any question, please let me know. Otherwise, we'll go for disadvantage and risk. Any questions so far?
No, sir.
No, thank you. So if you don't have any question, actually, I guess I know that my previous students know that if you don't have any question, that means you understand everything or you have understood nothing. So I guess you understand everything rather than nothing. By the way, one more thing, when I ask question, only 2 or 3 students reply. I don't know about the other, because all of you are don't understand. Let me, okay, what actually I can do after finishing it, I will ask you individually that tell me whatever you have understood, although we don't have time either. So let's continue. So that is the advantage of CISC processor. Let's see what is the disadvantage of it. Of course, we have some disadvantages. These are the disadvantages of it, right? So it's a very quite long one. So the first disadvantage of the CISC processor is, although the memory size or the core size is very, very, short, but the problem is whenever you write one single code or one single line of code of an assembly language, is actually required more clock cycle. I mean, 1 clock cycle, 2 clock cycles, second clock cycle, depends on the speed of the microprocessor. So each code requires actually multiple clock cycles. That means it takes more time for the processor to execute it. Okay. For example, you have just write add variable 1, variable 2. Okay, that is the instruction. Although it's just one line code, but behind it, microprocessor needs more time to do this instruction, because in that add there are four other instruction inside it. So the microprocessor actually need more clock cycle to execute this one. So although the instruction is just very short, but the clock cycle is more. That means the time requires it's actually more. So there is a disadvantage. Implementing, okay, the pipelining is one of the things you can learn in the microprocessor. Whenever you do the microprocessor, pipelining is whenever you have multiple tasks. Whenever you have multiple tasks, some of the microprocessor cannot do at the same task at the same time, all right? Because it sometimes microprocessor doesn't have a multitasking option. It actually needs to do one by one. So it actually have a pipeline, do one by one. So I have done the first one, then I go for the second one, the third one, the fourth one. So this is for pipelining. So whenever you have multiple instruction, the pipelining instruction is a little bit complicated for the microprocessor. Okay. Third one, of course, it's a complex one, by the way. So, but the problem is the CISC processor thinks more about the hardware part. Okay, although it's very complex, it's think about how we can reduce the hardware users, how we can do this one. But if you don't think about the software, it's not like that. I will explain it more whenever we compare with the CISC and this. Third one is actually, I think it's the same, memory smaller, the processor. By the way, the problem, as I said, that why we use CISC processor previously in 1970 and 1980, because in that time the memory was very narrow, and it was very expensive. But nowadays the memory is, we actually can have much more. Like for example, my one is 16 GB memory, very large one, and it is very cheap compared to the 1970. So previously, when our memory is very short and now it is very expensive, at that time CISC processor architecture is fine. But now in our modern life, we have large amount of memory and it is very cheap. So this kind of processor is actually doesn't match with it now, because we actually don't need to save the memory at the moment, because we have very wide memory and it's very cheap. So that is actually a disadvantage of the CISC, that nowadays this is actually doesn't match with the kind. So that is a disadvantage. Hopefully you understand all this. Okay, so let's do the CISC, the RISC processor. Let me see how much time we have. Okay, need to do a little bit hurry. Okay, what is the RISC then? The RISC means, actually, of course, we know the reduced instruction set readers. What is the difference? If you think about the CISC and RISC processor, they actually write very small number of, I mean not small, very short, but large amount of instruction. Okay, for example, as I give you the example of the CISC, that if you want to add two numbers, we just need to write add variable 1 comma variable 2, that's it. But if you want to write the same add instruction for the RISC processor, it is not like that. What it will be, it will be like, you need to load variable number 1 into register 1. Second line, load again. Mute please. So load the second variable into the second register. Then you need to add, and then you need to store the result into the first register. So we actually need 4 simple but 4 instruction to do the same task of adding. So you actually can feel that previously we just write one line of code in the CISC, but in the RISC we need to write 4 lines of code. That is the difference. Okay, but the interesting thing is the CISC one, which is just a 1 line, is very complex. Inside it there are so many, it requires more clock cycle. But for the RISC processor we actually have 4, right? Load, add, and then store. But each one are very simple one, and it's require only 1 clock cycle for doing one. So for the CISC, it altogether is 4 clock cycle, but in the RISC it will take 1 plus 1 plus 1 plus 1, 4. That means same thing, but each one requires just 1 clock cycle. So that is actually overall the RISC and CISC. Okay, actually is written in the same thing. One important thing, as I said, that CISC processor using the memory, right? but the RISC processor is actually directly to the register of the processor. Okay. All right. And sorry about that. And one more thing, in the RISC processor, we use the separate load and store instruction. We will discuss it later. We'll discuss it later, but let me see the example. See, very, very interesting. We use the RISC processor in IBM processor, in the SPARC, in the MIPS. By the way, this MIPS is very, very, popular in our assembly language. Course, we will do this MIPS. Okay. Another one is the ARC. It's very, very popular. I think you know the ARC and ARM architecture is very popular because the is using in the embedded system. As you can see, the ARM architecture processor is using for the smartphone, tablet, computers, iPad, and everywhere. So it's very, very popular, the ARM architecture. And also the ARC architecture, very popular. MIPS is also very popular. As you can also see, RISC processor nowadays is getting more popular compared to the CISC one, because we have enough amount of the memory. So the RISC processor now, for example, the supercomputer. I think I told you that nowadays the most powerful supercomputer is in Fuzuku or something. So that actually using this RISC processor, not CISC. RISC processor, supercomputer. Some of the Unix and Linux operating system also using this one, and the embedded system like our printer, router, and the simulator, they're also using the RISC processor. So it's very, very popular nowadays. Okay, so that is the RISC processor. Let's see what is the advantage. I hope you already know what is the advantage, that it is very, very simpler and a fewer machine instruction, of course. It's by the way, it's hardwired. By the way, I hope you know what does it mean, this word hardwired. Hardwired means whenever you write the code is actually attached with the hardware. Okay, whenever you write the code in the RISC, it's actually will be attached to the hardware, like our ROM, like our BIOS. Already we can change the BIOS. Everything is now smarter, by the way, but still this RISC processor is actually hardware. So that's why hardware requires less time, because it's inside the hardware. Okay. Of course, it's simpler. Execution time. The most important thing is the last one. See, I already told you that it executes one section once clock cycle. Although we have 4 instructions, but each instruction we just require 1 clock cycle. So it's a very good advantage. Let's see, there are some disadvantages, although not that much, but still we have some disadvantage, which is the RISC instruction size is reduced, but the more instructions are required. That means previously in the CISC processor, we just need to execute 1, right? But in the RISC, we need to execute 4. That is the problem. Machine instruction and hardware, that's what I said, that it is hardware in the RISC. That means the code actually integrated with the hardware. So if you want to change it, if you want to change the instruction, you actually need a lot of effort to change it. Okay, because it's inside the hardware. Sometimes it cannot be possible. Sometimes it's required more resources to change the RISC coding. So it's actually a problem. And it's while difficult to compress instruction and compress at decimal mode is not a problem. So, and the instruction do not allow. Okay, yes. As I said, that the CISC processor is using the memory location, and the CISC is using the register location. That's why it is not allowed to use direct memory access. Okay, so it requires a load, store, and something like that. Then you actually can go to the memory, but directly you actually cannot access the memory location because it's using the processor register. On the other hand, CISC processor, the previous one, can easily access to the direct memory because it's working with the memory. That is actually the problem. Okay, fine. I think we can stop here. By the way, it's the last slide before we go. It is the difference between the CISC and RISC. As you can see, this is the last slide, by the way. The CISC is more emphasized on the hardware because we need to reduce the number of memory. It doesn't matter how long, how complex it is, but we need to reduce the hardware use. That's why it's more emphasized on hardware. But on the other hand, RISC is more emphasized on the software. because you actually don't think about the hardware, because it doesn't matter how much register we need, doesn't matter how much memory we need, just make it more faster and less complex. So that's why it says it's actually software emphasized. As we know, CISC is using memory to memory. All right, so it's actually using memory to memory, whereas the RISC is using register to register. It's a small code, but it requires high clock cycle, right, per instruction. Whereas in the RISC one is the low clock cycle per instruction. Okay? But the size is, but the code size is big. But the per instruction cycle is very low. That is the difference. Transistor used for sharing. Yes, it's a transistor is used for storing the complex data. Whereas because if the CISC require only one transistor, at the same time the RISC actually require more transistor. I will show you the example when I come to the next class. In this CISC we need one transistor for doing one thing, but here we need 4 transistors for doing the same thing. So that's actually a problem. The machine language instructional sequences are very inlet. Okay, yeah, that is the interesting one. Whenever you write the CISC code, the length of the code of the CISC actually varies. The size of the code is actually varies when you convert it into the machine language. But whenever you write in the CISC, the machine language length is actually the same. So the machine language length of the CISC is varies. Sometimes it's big, sometimes it's large. But for the RISC, it's actually the similar size. Okay, so that is actually the difference and all thing about it. I think you can understand.